We have our ECBC Master Trainer, Mr. Arpanpal, with us today. He is a Felix Scholar and European Campus of Excellence member. He holds double master's degree in renewable energy and environmental sciences. His work experience includes performing environment impact assessment, environment due diligence, and delivering LEED certified projects with public and private entities in various countries like India, UAE, and Malaysia. We are extremely thankful to you, sir, for your presence here. I welcome Mr. Arpanpal for this session. Over to you, sir.
Hello everyone. I've been working in this field for some time now, and I have, like, although my basic is in environmental sciences, but I have uh, about 7 to 8 years of experience in this field of energy simulation and green building certification through eQuest and IES. And again, as I did my ECBC Master Trainers course in 2016, and since then I've been taking trainings for ECBC, mainly in the energy simulation part. In various states, like I've done one session with ECBC Kerala earlier, I think last week around the same, last year around the same time. And I also did some trainings in Assam, Amritsar, and Bhubaneswar as well. So that is a brief about myself. I have been involved in a number of LEED, Griha, and IGBC projects as well, because of which I think I have some knowledge of what ECBC is, and I hope that through this session I will be able to help you to get an understanding of what ECBC is, and then how it was developed, and how the eQuest runs. I mean, just a brief hands-on session on how eQuest runs. I believe you all have been shared with the links to download the eQuest software along with the file. So all those things will come handy. Shrikant, have all the participants you received those links?
Actually, they have got the links, sir.
Okay.
All the participants. It's almost we have a targeted people from 40 to 50. We have actually 28 people now.
Okay.
So I think
So,
the others, yeah, it's 29. The others will come within 5 or 10 minutes. Just leave it, sir. We can start, sir. No problem.
Sure. No problem. No problem. I will have. Just a moment. So just for today's session, I believe the entire session, the entire program will be divided over 3 days. Today is the first session, and that will be about 2 hours sessions. And then tomorrow it will be again 2 hours in the morning and 2 hours in the afternoon, and similarly on Saturday. So through this we will cover all the syllabus that has already been shared here with you. But for today, what we will do is we'll go through ECBC. I hope you can see my screen, right? Well, is my screen visible to you all? Hello.
Yes, sir.
Great. We'll try to make it a bit interactive. As you can see, I mean, as I can see on the call, that there are a lot of experienced people in their own sectors in terms of architects, your mechanical engineers, civil engineer, and environmental consultants maybe, and then you all have your experience in the field, which is more than what I have. But what my role as a ECBC training, as an ECBC trainer is just to put things into perspective from an ECBC point of view, and to just explain like how things work and then what are to be done to make a building ECBC compliant. Just a note that please feel free to ask any questions in the middle of the session whenever you can, right? So that this session can be more interactive that ways. I just want to ask one thing. Are you able to see the presentation or the other screen? I'm not sure which one has been presented. I have two screens on mine. Hello?
Your energy conservation building code presentation has been
Okay,
shared.
that's great. Okay, that's great. Okay, so to start with, just to get an idea of what the energy conservation building code is. So this first session that we have today is more about an introduction of ECBC and then how it came to be and then how it fits into the entire energy scenario that is currently there in India. Right. So if you see the first slide, India, just in the perspective of how things are here in India. Um, so India is expected to add 1 billion square meter of new commercial buildings by 2030. So as you may know that building sector, the construction sector in the operational phase amounts to a huge percentage of a country's energy consumption. So adding 1 billion square meter of new commercial spaces by 2030, just imagine the huge pressure that will come on the energy consumption of the country, and that added with the reducing fossil fuel availability and then the technological upgradations and everything that is expected to put a heavy amount of pressure on the natural resources. So in itself, so it makes all the sense from a technological, from an administrative and from a management point of view to use the natural resources, which in this case is the non-renewable fossil fuels, more judiciously so that we can conserve them and then we can expand it as and when so that it lasts longer than expected. Sorry. Okay. Then likewise, India's residential sector is also growing at a huge pace. Also, well, although following the COVID pandemic, the entire economy has taken a hit, and then it has just experienced a slump at the moment. But then things are expected to grow up, and then and India is expected to add about 3 billion square meters of residential space by 2030 with respect to the base year of 2018. So when we say about the energy conservation building code, all these things were realized by our government way back in 2000. In January 2000, the government of India and the American and the USAID, they signed a bilateral agreement that was aimed to enhance the commercial viability and performance of Indian energy sector and to promote utilization of clean and energy efficient technologies in the USA. So with this, and this was the basis based on which the Energy Conservation Act was formed in year 2001, and that is called the ECO 1 project. ECO stands for Energy Conservation and Commercialization. This was the overall plan that was signed by the government of India and USAID. And then based on that, the Energy Conservation Act 2001 was developed, under which the government of India established the Bureau of Energy Efficiency under the Ministry of Power. This was further upgraded to a Eco 2 project, during which BEE was again supported with all necessary assistance and then training programs that led to the ECBC development. So the ECBC that you're seeing now was started under the Eco 2 project. And then once the ECBC was developed under the Eco 2, the Maharashtra Energy Development Agency was also assisted in developing strategy for ECBC implementation, and some pilot projects were also implemented in Karnataka that related to replacement of incandescent lamps with CFL. So under Eco 2, these were the main developments that was done. And then from 2006, the Eco 3 project came into being, under which the ECBC 2007 was developed. So in that, the main thing was ECBC was provided with tip sheets and then design guides, and all these awareness, these ECBC awareness programs that is happening right now. This session is also part of the ECBC awareness program that is under the Eco 3 project, right? So all these started to develop since 2006. So at that time, if I remember, the main purpose of this entire collaboration between the government of India and USAID was primarily three things. One was to so the first one was capacity building, that was creating ECBC trainers, ECBC auditors, and then ECBC energy managers. So all those things were a part. So I think at that point they had a target of training X number of people to become auditors, energy managers, or trainers. So all of us who are ECBC master trainers were covered in that part of Eco 3 project. The second one was again these awareness programs that is happening right now. So they had a target that, okay, after creating the master trainers, auditors, and energy managers, we need to develop the capacity at the grassroots level. That means at the government, at the so all these training sessions that are happening right now that include the ECBC cell who is approaching the government architects and the development authority architects, engineers, them to be trained in ECBC. So yeah, that was another objective of the entire Eco 3 project, where after developing the trainers, you train people at the grassroots level who are actually doing the day-to-day work in making the buildings. So they need to be trained in ECBC. So that was another objective of this Eco 3-year project. And there was another objective that was done was building some pilot projects. I think I may be wrong with the number, but I think it was, they had a target of about 15 to 20 pilot ECBC projects they would build in every state, right? Something like that. Not every state. I've been, some were chosen. I was fortunate enough to be part of one such project that was they had chosen the Uttar Pradesh Electricity Commission building to be that one ECBC pilot project in that region. So the idea was, now if you see under this Eco 2 project, the entire ECBC development was done for 5 climatic zones, right? Which of course will come later on what the climatic zones are. So if you see the ECBC development that is done right now, the one that is now, this ECBC provides guidelines of how to develop buildings that are mainly categorized under 5 climatic zones, because as India has a huge geographical expanse, and they are spread across a number of climatic zones. So the entire country was subdivided into 5 climatic zones, which are mainly a composite. Sorry, we can come to that year later. We have that in the subsequent slides. Okay. Then comes the purpose of ECBC. As we said, as we now have an idea of what, like how this ECBC came to existence. First of all, just to summarize what we came through up till now. First, there was an agreement in between Government of India and USA, right? Based on which there was the Bureau of Energy Efficiency was formed under the Energy Conservation Act. And then based on that, the Bureau of Energy Efficiency developed the ECBC code that came under Eco 2 project. And then that was further developed in the Eco 3 project through other objectives of capacity building, pilot projects, and awareness. Now, the main purpose of the ECBC is to provide the minimum requirements for the energy efficient design and construction of buildings. So through this code, what BEE wants to achieve is just to give you the minimum set of design criteria that anyone should have while designing a building, and also while assessing. So on the development authorities side, people who can assess, they should know, okay, what all things to see, so that I can realize or I can determine whether building is ECBC compliant or not, just to give that. And then it also provides the additional sets of incremental requirements for buildings to achieve enhanced level of energy efficiency that go beyond the minimum requirement. Now, there are 3 levels of ECBC. One is the simple ECBC, just the ECBC. Then is the ECBC plus, and then is the super ECBC, right? So not only it gives the minimum requirements, it also gives you that, okay, if you want to aspire higher than ECBC, if you want to make your building more than what is generally required, these are the set of your guidelines. And then if you do this, you achieve, then your building will not be called as ECBC compliant. It will be called as ECBC plus compliant, or super ECBC compliant. So in general, now the scope of the ECBC, now this has to be very clear, because these are the basics. So whenever somebody wants to do an ECBC, they need to be clear about the applicability of ECBC in the for this. So if you have a connected load of 100 kilowatt or greater, or a contract demand of 120 kVA, then and your building is a commercial purpose, then only you go for then only ECBC is applicable to your building. So as you can see in the last point, it says buildings intended for private residential purposes only are not covered by the code, right? So residential buildings are not covered by ECBC. They have a separate rating, sorry, not rating. They have a separate code. I think it's Eco Samhita, right? So Eco Samhita is for residential buildings, but for ECBC this is only. So you just have to have two ticks. One is your building is not a residential and it has a commercial purpose, or it has an institution. So anything that is not residential is the first check. Okay, my so if you want to develop a checklist, the first point is my building solely intended for residential purpose or not? If yes, then ECBC is not required. If no, then there are certain other classifications that ECBC gives, which will come in the next slide. And then the second criteria is what is the connected load or the contract demand. Contract demand means this is how much you have asked from the utility companies to provide you, and connected load, right? So these are the two. If if your building is commercial but the connected load is lower than 100 kilowatt, then ECBC is not applicable. Then you can choose not to apply ECBC, right? Please feel free to ask any question in case of any confusion. So up till now, is everything clear? Is there a way I can see if people raised hands here or not? They able to see Susan. Okay, okay. Any questions? Any comments? Anything from your experience? Okay, there is a comment.
Yeah,
Mr.
sir, there is a
Yeah.
question, sir.
Yes.
Is there
Please.
relation? Is there a relation between ECBC, ECBC Plus, and star rating of buildings?
ECBC Plus and star rating. Star rating as in?
Is there a relation between ECBC, ECBC Plus, and star rating? That's 3-star, 5-star, star rating of buildings.
I think star rating is a different thing. It is not covered. I mean, you can see ECBC and ECBC Plus is same. It's just that the design criterias are separate, right? And star rating is provided by BEE, I think, right? That is not covered in the ECBC. That's a separate thing. It's not related. But then ECBC and ECBC Plus, they are just two different types of compliance. Is that clear, or do you have any other follow-up questions? Okay, I will take that as there's no follow-up questions. Okay, so we have, okay. So then we go to the ECBC scope of ECBC again. Well, as said in the slide, so Mr. Joseph, your half of the questions you can see in this slide, that the energy efficiency performance. So the ECBC code 2017 prescribes the following year level of the energy efficiency. First is the ECBC building, second is the ECBC plus, and the third is the super ECBC. So ECBC plus and ECBC, they are just different levels of ECBC compliance. They are pretty much the same thing, right? So if you achieve ECBC plus rating, then you are automatically ECBC compliant, right? That means. No. Now, scope of the ECBC appliance. So, what components in a building is applicable to ECBC? I mean, which all factors can an architect or an MEP consultant or the project team can look into to make their building ECBC compliant? First is the building envelope. The building envelope refers to the outer shell and the superstructure and the non-structural aspects as well. That means the roof envelope, the glazing, the external wall, above ground and underground, internal walls, floors and ceilings. So these form the building envelope. So if you design your your building choosing the right building envelope, you can make your building ECBC compliant or ECBC plus or super ECBC. So ECBC buildings prescribe a definite set of building envelope criteria that you can do. ECBC plus sets the same criteria, but it is a bit aspirational that way. Likewise, there are building systems. By building system, we mean the comfort system and the controls. So the way you control your air conditioning, the way you control your lighting, that aspect, if you design it that way, you can achieve your that way you can make your building energy efficient and ECBC compliant. Then lighting controls, as I said, by controlling now lighting control is of two types. One is the operational control, that means adding time switches and all, or having sensors, so that the operational aspect of the lighting is you can be controlled and optimized, so that when lights are not required, they can be switched off automatically, or there is some gas system. And the second thing is the installation capacity. So not installing higher lighting. So that is in form of the lighting power density that is said, that is defined in terms of the amount of kilowatt of lighting installed per square meter or per square feet. That is a parameter that ECBC prescribes, that okay, you ensure that you do not install lighting that is more, that is not necessary, so that you optimize your lighting installations. Then the third system is the electrical and the renewable energy system. By electrical system, you mean what we mean here is the transformer and the power factors and those aspects. And renewable energy system, of course, if there is anything renewable, I mean, it can be solar. Solar is just an aspect. It can be wind energy, it can be geothermal or whatever, or heat pumps.
Excuse me, sir.
Yes,
May I interrupt,
please.
sir? Sir,
Sure.
actually, sir, with I think your full screen is not visible. That's why, sir, seen just as small. Can you,
Okay.
instead of sharing screen, can you share the app so that it will be visible?
Okay. How do I do that?
So first of all, you just want to put the full screen. That's slideshow. It's on the right side bottom.
This one.
Yeah, that one. Yeah.
Okay.
Okay, and also in your GoToMeeting, can you please go there? Just click on Alt tab, sir. Alt tab. Alt plus tab. Alt plus tab.
Okay. Alt plus.
Yeah, Alt tab. Alt tab.
Alt tab.
Yeah.
Okay.
so that go to meeting. You can go to meeting. In that it's not visible. Yeah.
Now,
No. No, sir. This is not. Go to meeting. Can you click once again, sir? Alt tab. Or you can simply click on display settings on the left side top. Display settings. Left side. Sir. Display setting. Left side top.
oh, okay, yeah,
Yeah.
display setting,
Then present away.
present review.
Yeah. Now it's fine, sir.
Okay, it's fine now.
Thank you, sir. Yeah.
So, okay. So, yep. This somehow. I'm somehow not able to take the slideshow back. Okay, I have to do okay, yeah. So just to summarize what on the scope of the ECBC first is your building should not be solely residential. Your building should have a contract demand or a connected load of sorry, your building should have a contract demand of 120 kVA or higher, or a connected load of 100 kilowatt or higher. And then the scope of the ECBC is limited to the building envelope, which means your wall, glass, roof, external wall, internal ceiling, internal partition, floors. Then is your control systems and your building systems that include your HVAC systems, your efficiency, your controlling of the zones of individual zones during the operational hours, your lighting, installed lighting, and your lighting operational control, and then your electrical systems in terms of the transformer, the losses, and then any renewable energy. In the renewable energy, it is not only just electrical. There is hot water. So any building that is that has hot water requirement, there is an option that there is a mandatory requirement in ECBC that certain part of that hot water has to be supplied from renewable energy. Now, renewable energies of hot water sources can be solar or other, I mean, heat pumps at times. So that depends on where your building is uh, and your design team. Then your provisions of the code do not apply to plug loads, equipments, and parts of the building that use energy for manufacturing process unless other specified in codes. Now, any part of the building, say if we are doing a factory or any say aspect that or it has a component of energy without which the operation of the building will be jeopardized. In that case, those things will not they can be they will not form a part of the ECBC. So your plug loads. ECBC does not tell you that you should install maximum of 10 computers or 20 computers in this amount of square meter space. No, that will totally depend on the requirement of the building and then what the building is for. So if there is a commercial space that has offices, it will not tell you. And then it's not only ECBC. No one can tell you how much computers or plug loads you will require. That is not there. And then secondly is any processes. So say in the kitchen, any commercial building, there are
kitchens will not say that, okay, this is the maximum kilowatt of load you can have in that. So processes is something that that is out of the scope of ECBC, along with plug loads and other things. Precedence, what it says is, how do I know that in what, I mean, there will be circumstances where ECBC code will have certain things that clashes with other policies and things. So precedence here sets that in what case ECBC will be applicable and ECBC will not be applicable. So as you can see on the screen, that that any policy notified as taking precedence over this code or any other rule on safety, security, or health by environment, health or environment by central, state, or local government, in that case, ECBC will not be applicable. So this means that anything that is notified by the central, state, or the local government that this energy consumption of this component is for the health and safety of that region, in that case, you cannot make ECBC applicable to that. I'll just give you a small example. Say defense settlements, or say defense establishments. In defense establishment, you have high requirements in the like in the fencing region. ECBC cannot say that no, there you have to limit your lighting LPD by this much, because that is for the security reasons. Anything that is of emergency, that for which that will interfere with the purpose of that thing, ECBC will not be applicable. Right. Similarly, Bureau of Energy Efficiency Standards and Labeling for Appliances and Star Rating Program for buildings, provided both or either are more stringent than the requirement of the code. So ECBC, so if anything, if Bureau of Energy Efficiency says that, okay, in this case, this standard and then labeling and these things will be applicable, in that case, those will take precedence over ECBC. Right. Now, reference standards, the main reference standards, as I believe there are a lot of architects in this team. The National Building Code 2016 is the reference standards for lighting level, HVAC, thermal comfort conditions, natural ventilation, and any other building materials system design criteria addressed in this code. So ECBC 2017 takes its references from the NBC 2016. Now comes the building classification. If you remember earlier, we had said that ECBC building, the first criteria of checking whether your ECBC is applicable or not, right? That mainly depends. So the first question is whether your building is solely residential or not. If it is not residential, then what it is. That means this classification is new in 2017. In 2007, this was not there. So under ECBC 2017, buildings, so under commercial buildings, ECBC has classified them into different classes based on which the requirement of the ECBC design parameters are based. So hospitality, which includes your star hotels, no star hotels like lodging houses, dormitories are also falls in this hospitality section. Resorts, these are the three main things. So any resort, any hotel, star or non-star, if it is a hostel or something, right? Or the dormitories, bread and breakfast, they can go on ECBC, and if they go, they will come under the hospitality classification, and they have to meet the requirements of the hospitality classification. Right. This is only if the owners choose to be ECBC compliant buildings. Likewise, the second classification is educational. So any college, university, institution, schools, they have a different set of requirements under ECBC 2070. Right. So here, so any colleges, universities, even hostels. Again, if you say hostels, hostels becomes a bit that is a sort of a gray area. So hostels within the college campuses, they may choose to comply with the hospitality thing because that is used as dormitory. They would be classified as a dormitory. But any educational buildings, say lecture halls or say laboratories, engineering blocks or anything, that will have to follow the educational requirements of the ECBC scope. Likewise, the third building type is the healthcare. So any hospital and even outpatient healthcare, they form the third classification, and then they have a different set of requirements under ECBC. The fourth one is the shopping complex, so any shopping mall, standalone retail, open gallery, mall, supermarkets. They can also choose to be ECBC compliant as well. The next one is businesses that include large offices. So anything that is more than 30,000 square meter, medium offices 10,000 to 3,000 square meter, and then small offices that is less than 10,000 square meter. They will be under the business classification under ECBC. And assembly buildings, these will be mainly multiplex, theaters, business, or buildings used for transport services. This will be like, say, transportation hub, or say railway stations, or say bus terminuses, and all those things. So they will be under the assembly building. Now, up till now, what we have covered is how was ECBC developed, what is the scope of applicability of ECBC, what parameters in the building design ECBC influences, and then what is the main purpose of ECBC. These four things we have covered up till now. Now comes how do we comply with ECBC. Now there are mainly two approaches, right? One is the prescriptive approach, and one is the whole building similar, whole building simulation approach. So these are the two ways of approach in which you can show that your building is ECBC compliant or not, right? In this, as you can see, now the main parameter of saying that, okay, my building is compliant, the main factor is EPI, right? So EPI is the energy performance index of a year building. That is mainly its annual energy consumption in kilowatt hour per square meter of the building, that is calculated by the annual energy in kilowatt hour divided by the total built up area excluding unconditioned basements. So from the calculation of you will not consider your unconditioned basements. If it is there, you do not you consider that in your calculation. That means if you have your basement, you will not consider that area. Apart from that, anything the built up area, that and the total energy consumed by the building throughout the year, right? Divided by the total building area minus the unconditioned basement area. This is how you will calculate the EPI. Now, to comply with the code, EPI shall be calculated based on either the prescriptive method or the whole building performance method. So I think 3 sessions. I think tomorrow and day after tomorrow is only based on the eQuest. eQuest will show you how to do this whole building performance method, and prescriptive method we will also see. That includes building envelope trade-off method. What this building envelope trade-off method means? Now, if you consider, I mean, if you see energy conservation, it has a cost factor as well, right? So ECBC gives you that flexibility to overperform in something else and underperform in something else, that so that you can stay cost effective. So say if there are some components of the building envelope or building system or the electrical systems that are high cost, that have high cost implications, you have the option of doing that assessment to figure out if I don't do certain percentage of that high cost implication aspect, but I overdo some of the low cost, can I meet them? So that flexibility is there. So for example, if there is a building, right, and there having say double glazed glass does not make any sense, because say it will be occupied only in the early mornings and say evenings, right? I'm just saying as an example. In that case, having a double glazed wall, which has double glazed glazing, will not make sense, but it has a high implication, high cost implication. That way, you are able to make an assessment that okay, if I don't invest much in the glass, but if I say have another layer of brick, and the same, you can do that that trade-off calculation to see okay, if am I meeting ECBC requirements through prescriptive way, right? By not including double glazed wall, but okay, if I do this much of double wall on the north and east side, then I'm being cost effective, but I'm also meeting the ECBC requirement. So that thing comes under the prescriptive gear method. And then the whole building performance method, that obviously gives you that trade-off option, but in that, the main thing is in the whole building performance method, you are able to choose the different systems, and you're able to see that yes, whether my room or whether my space where people will be sitting, whether they have the thermal comfort or not, and then how much energy I am conserving in the entire year by varying the by incorporating the diversity factors. Diversity factors in terms of not your all spaces will not be occupied throughout the day, right? In the lunch times in an office space, people will go out for lunch. Some people will come late to the office, right? Some people may leave the office early, some people may leave late. So all those things, all those variations, you can set profiles in eQuest or any energy simulation software to factor for that variation. Similarly, your lighting may not be on throughout the time. You can add the profiles in your lighting in eQuest or in any other simulation software where you can say that, okay, from morning 9 to 12, 90% of my lightings will be on. From 12 to 2 lunchtime, only 20% will be on. And again 3 to 6, 90, and then the rest of the day is 0.5%, just 5% for security reasons. So all those variations you can do in the energy simulate in the whole building performance method. That ways you are able to factor in those control systems that will reduce your annual energy. So if you are designing a new building, we would suggest, or it is more suggested that you do the whole building performance method, because that way you will get a much realistic scenario of your building that will be working in the operational phase. Right? In the prescriptive way, you will just calculate the building envelope, but all these variations you won't be able to factor it. It is just a matter of installing this with this efficiency, installing this with this heat value, installing this with this power factor, distribution losses less than this, something like that. But then through a whole building performance method, you will be able to factor in all those scenarios that will actually happen when the building is operational. You can add a profile for lighting, you can add a profile for your equipment, you can add a profile for your occupancy, you can add a profile for your, say, hot water, that okay, I want my hot water supply from only 1 to 2, something like that. Sorry, if there are some questions, please feel to speak. I see one one question. Hospital, which category? Hospital will fall under healthcare. So if I go back on this, so healthcare, hospital, and then outpatient healthcare. Under this category, hospital will come. Sorry, I saw this comment a bit late. Then again, so now as you understand what the main difference in between the prescriptive and the whole building approach is, what we can see is how to determine the EPI ratio. So for proposed building, so how to know that whether my building is ECBC compliant. Okay, I have determined my EPI, right? Now whether that EPI is ECBC compliant or not, how do I know? That will come from the EPI ratio. Now the EPI ratio is the ratio of EPI of the proposed building divided by the EPI of the standard building. Proposed building is what you will be designing, right? All the U values and glazing will be as per your choice of materials that you will implement. And EPI standard building, as you can see, standard building is a standardized building that has the same building floor area, gross floor area, gross roof area as the proposed building, and complies with the mandatory requirement of section 4.2, 5.2, 6.2, 7.2. So that means a building that meets the minimum ECBC criteria. That forms your standard building, and your proposed is what you're actually proposing. So how does it say that EPI ratio to the prescriptive ECBC buildings that demonstrate compliance to prescriptive shall be deemed to have EPI equal to the standard building and therefore an EPI ratio of 1. So if you are showing compliance, showing ECBC compliance through prescriptive way, then ECBC buildings just have to show that your EPI ratio is 1. That means your EPI of the proposed and the EPI of the standard is the same. That means the energy consumption of your proposed and your standard building should be the same, right? And then, but if you're going for ECBC plus or super ECBC buildings, you have to show that EPI ratios equal what is given in section 9.1 under the ECBC code, right, for different climate zones. So I think it is given somewhere here. Let me see if I can jump to the, yeah. So if you can see here, for different types of your buildings, ECBC has given the maximum allowed EPI ratios. So for hotels, star and non-star, if you want to opt for ECBC plus, then your EPI ratio should be 0.9. That means your EPI of the proposed building should be 9% less than the EPI of the standard building. And like so, that means 9% saving, energy savings. And likewise, super ECBC, the EPI ratio should be 0.81. That means 19% energy savings. So that means any hotels who are opting for super ECBC, they will have to show that that their energy consumption is 19% lower than the standard year building. Is this clear? I mean, please feel free to ask any questions. Is there any questions on this? You can type your question in the chat box as well. Okay, there's a question that can we achieve higher rating in Griha by designing an ECBC compliant building? Not necessarily. Not necessarily. Because Griha, because energy efficiency is a part of Griha, right? It is not all Griha with a higher. In Griha, the minimum you have to do is ECBC compliant. That is the minimum, and that is the mandatory requirement, right? Whereas to achieve some scoring under Griha, I think you have to achieve 20% saving for 2 points, 30% saving for 5 points, something like that. There is a scoring. So if you do an ECBC compliant building, just ECBC compliant building, you will just meet the mandatory requirement of Griha, right? Whereas if you say do ECBC plus or ECBC or super ECBC buildings, in that ways you may get certain points under Griha, but that will not mean that you can achieve higher rating in Griha, because other aspects are also seen into Griha. For example, landscape, for example, site-related criteria, then your ventilation, then the use of AC blocks or just making the buildings lighter. So there are other factors that contribute to Griha rating as well. So hence, just complying with ECBC will not give you like a higher rating in Griha. Then there's another question: what is a standard building? Standard building is the theoretical building that meets ECBC requirements. Say you are designing a building, say for 10,000 square meter, an office building for 10,000 square meter, right? Your standard building will also be 10,000 square meter, having the same floor layout, but the building envelope, the building systems, the electrical systems, and renewable energy component, they will be as per ECBC requirement. Whereas your proposed is what you will actually do. So say for example, you want to achieve for super ECBC. So you are incorporating U values that are required for a super ECBC. But your standard building will mean that the same building but incorporating the U values of just ECBC. So if I go back to the slide, wait, there was a definition of standard building here. Yeah, a standard building has the same building floor area, gross wall area, and gross roof area as your designed building, but it complies with the mandatory requirement of section 4.2, 5.2, 6.2, 7.2 of ECBC and minimally complies with the prescriptive requirements of 4.3, 5.3, and 6.3 of an ECBC building. So if you are designing an ECBC plus building, then your standard building will be the same building but complying with just ECBC. In that case, you are already performing better. So that is how you establish your savings. So the main idea behind it, that is you should perform either equally or higher than the standard building. That means your standard building energy consumption should always be higher than your proposed building energy consumption. Hope that is clear. Then there is a question that will this vary with warm, humid? Yes. So if you can see, this will vary with the climate. As I told you, that ECBC has developed standards for 5 climatic zones. So this one is just for the composite climate. Now, what is composite climate? I'll show you a slide. I can show you a map that is there in the ECBC 2017 that gives you those climatic zones. That ways you can, based on the location of the building, you can see that what climatic zone your building falls under, and then what ECBC ratio I should score for a climatic building. So these are the requirements for composite. These are the requirements for hot and dry. So you can see that there are slight differences on the requirement of the maximum allowed EPI ratios for different climatic zones. And then there is temperate, there is warm and humid, and there is cold. So these are the 5 major climatic zones as per ECBC. I think, yeah, this we have done. Okay, now we are coming to EPI ratio through whole building performance method. In this, the EPI of the buildings that demonstrate compliance through whole building performance method shall be calculated using the compliance pathway defined in section 3.1 and detailed in section 9. Section 9 of the ECBC is sort of the Bible or the guiding section if you are doing an whole building simulation approach ECBC compliance. What section 9 shows you, after this after the presentation, I'll just quickly take you through the various sections of the ECBC so that you are aware of what chapter says what, and then everything that I am showing you in this slide, they will start to make sense, if it is not already. Okay, the section 9, what it says is, so in the whole building simulation, you have to make 5 scenarios. One is your proposed scenario, right? Your proposed scenario will have all the parameters that you are actually doing. If you're not doing a double glass, you will have a single glass U value in your proposed case. Or say if you are just doing double glass on the west and the south side, and the others are the normal, then you do that. If you have shading in certain sides of the building, you include that in the whole building simulation as well. So your shading factor will also be considered factors. Right. So, and then section 9 also says that these are the things that you should do for a proposed scenario, and these are the aspects that you should include in the standard building scenario. That way, so it gives you the exact guidelines of what choice of systems has to be taken in the proposed and the standard set and the standardized scenario. What building envelope U values you have to take in the proposed and the standardized case scenario, and then what profiles, what occupancy profiles, lighting profiles, what equipment profiles you will have to take in the proposed and the standardized scenario, right? All those details. So anyone who is performing ECBC compliance via whole building simulation, section 9 is sort of your guiding document, right? And then it says the EPI ratio of the building that uses whole building performance method to show compliance should be less or equal to the EPI ratio listed in 9.5 for applicable buildings and climate zones. So there is a different set of EPI ratio for the prescriptive, and there is a different set of EPI ratio that is there for the whole building simulation here pathway. EPI ratio for core and shell. This is quite important because a lot of commercial spaces are are delivered in a core and shell model. What a core and shell model is that the developer builds the superstructure, they build the glass, they build the building envelope, and if applicable, they install all the high-end energy systems. So say like a chiller or air handling unit, they will bring and they will keep it well, and then they will provide the air connections on every floor, and then any tenant who is coming into the individual places, they will do the interiors, they will do the final tertiary system. So they can implement FCUs, or say they can implement the DAVs on the HVAC. The interior lighting will be there. So in a core and shell model, the developer's responsibility is restricted to a certain part. So the developer will give the lighting in the common areas, in the lift lobbies, and all those things. But the individual tenants, they will be responsible for having their own lighting based on their own requirement. In that case, for a core and shall be calculated for the entire building based on the final design of the common areas and relevant mandatory undertaking in the tenant lease agreement for the leased areas. So that means you need to have a lease agreement with the tenants that says that, okay, this is the maximum MPD that you can install, or they say that, okay, based on our requirement, I'm opening a showroom. So in that case, I need higher lighting. So based on that, they will give you an LPD. They will say that, okay, I'm opening this, but I need a higher cooling capacity. So I'll draw higher chilled water from your systems. If it is an if it is a chilled water system that we explained. So that is based on those finer details, right? Based on those finer details, the EPI for a current shell building will be based on whatever detailing is there in the common areas, and then based on the tenant lease agreements. Now, EPI ratios for mixed use. Mixed use, as in there will be projects that are half commercial, half retail, half office, or say half theaters, multiplexes, and stuff like that. So in a mixed use building, sorry, put this goes out. Yep. So in a mixed use building, each commercial part of a building must be classified separately, and EPI ratios shall be calculated separately for each sub-classification as per clause 3.1.2.1 or 3.1.2.2. That means if your mixed-use building has 60% area of commercial and 40% area as retail, you have to show that commercial aspect meets the EPI ratio requirements of the commercial side, and your retail meets the EPI ratio of the retail side. Or if there is a healthcare, that will apply as well. Okay, there is a question: what about the different flows in a standard building? Should we follow same as proposed one, or what about the profiles of the standard? Okay, we'll come to that, but just to answer your question, profiles of your standard building should be same as the profiles of your proposed building. You cannot say that the standard building people will sit 6 hours, and in my proposed building people will sit 3 hours. Your profiles of the lighting, that and so hours of occupancy, hours of lighting, hours of system working, they will be same in the baseline. Sorry, not baseline, in the standard and the proposed. That ways, what you are doing, showing that even if my system, my entire building is working same hours, I am still saving X amount of energy. That means I am designing the building much better than the standard. If you play with the occupancy hours, that means that, okay, so that means you're not you're designing the building nicely. You're just reducing the occupied hours to reduce your energy consumption. ECBC will only make sense if you design the building well through smart choices of building envelope, smart choices of control systems, smart choices of energy efficient systems, installation of renewable energy systems, so that even with same hours of operation, same load, same flood load, same occupancy, you are saving energy. That is the whole purpose. And what about different floors in the standard building? The difference, so the floor plan of the standard building and the floor plans of the proposed building will be the same. So you cannot have, say, floor to 10% of your area as unconditioned in proposed, and in your standard you cannot have 20% of that area unconditioned. So the space usage should also be same in the proposed and your standard case. Right. I hope I answered your question. Okay, now coming back to the EPI of the mixed use. The second point is, if a part of the mixed use building has different classification and is less than 10% of the total GFA, the EPI ratio of the mixed use proposed building shall be equal than or equal to the maximum allowed EPI listed in table 9.5 for the subclassification that have highest percentage. So say if my retail is less than 10% and 95% is commercial, then my EPI ratio for the mixed use proposed shall be less than or equal to the maximum EPI listed in this. So for example, if I go here, so if I have a project in the composite climate zone and I have an office, so 95% is office and say 5% is retail. So that means that 10% lower. In that case, I have to meet this 0.86 EPI thing only, right? I cannot do it separately. I'll have to do the higher one. That is the higher percentage. And similarly, if a part of the mixed use has different classification and is more than 10% of the total GFA of the mixed use proposed building, shall be less than or equal to the maximum allowed EPI for compliance based on area weighted method. So again, when I'm doing the final EPI, I'll have to do it on a weighted average thing. So if say 20% is retail and then 80% is office, then the final EPI will be based on the weighted average of the same. Okay, then I think we already went through this compliance approach. Okay, just a moment. Okay. Now, as we saw that we have to that we have two types of compliance approach. One is the prescriptive, and the other one is the code building simulation. But there are certain mandatory requirements that are minimum for all ECBC. So any building that is going for ECBC or super ECBC or ECBC plus, and whether and irrespective of whether you are going through the prescriptive method or the whole building performance method, you first have to meet the mandatory requirements of the ECBC code, and then only after you meet the mandatory requirements, then you can choose that okay, I can go by prescriptive or I can go by whole building simulation. So the mandatory components. So again, there are certain things under building envelope, comfort systems and control, lighting and control, and electrical system that are mandatory. Now these does not include U values and stuff. Those comes under the prescriptive. So after this presentation, I'll quickly show you what is the outlay of the entire ECBC code. That is, you will come to know, okay, what type of mandatory requirements are there, and then what are the prescriptive requirements, right? Now, compliance method options. So as I explained to you earlier, there are prescriptive compliance and the whole building compliance. So under the prescriptive, prescriptive requirements for all relevant sections must be met individually. A simple checklist form for demonstrating compliance. Easy to use but restrictive, no flexibility in approach. This is what I was saying earlier, that in the prescriptive you just have to meet those standard requirements that are mentioned in the ECBC. You cannot factor in your diversity factors, you cannot factor in profiles, and then this is easy to achieve because the compliance to ECBC can be shown just in form of a checklist. Now, how will that checklist look? The checklist will list all the prescriptive criteria that are there, and then on one side it will say, okay, this is compliant, this is the proof of the compliance, this is compliant, this is the proof of the compliance. For example, say U values. As per Super ECBC, say for example, the U value required for office space is say 1.9 watt per meter square, right? You say compliant with, and this is the proof. In the proof, you can give the section and the calculation of the value of the section. Similarly, glass. This is what is required under ECBC table 4.3 or 4.4. Compliant sigma. This is the U value of the glass that you have taken. This is the technical specification sheet, and this is the BOQ, or this is the purchase order. So that wise prescriptive compliance is done. Is you keep on showing that, okay, these are the requirements that are asked, and this is how we do those requirements. What is the main difference with that with the whole building compliance? Under the whole building compliance, the compliance is showed for the entire building. The overall target of energy kilowatt hour per year is met irrespective of the compliance at the component level. That means in the whole building, you can choose not to comply with certain aspects of the prescriptive requirements until and unless your EPI ratio for the whole building thing is satisfied. If your EPI ratio for the whole building thing is satisfied, you don't need to install pumps that have say 5-star rating, and then just say, but you have to meet the mandatory requirements. Only so as said in the last slide, mandatory requirements have to be fulfilled whether you are going for prescriptive or whole building. But certain of the prescriptive things you can choose not to implement, but like if you are showing compliance through whole building compliance. Okay. Certain exceptions. So trade-off process, that is an exception to the prescriptive method. The compliance can be demonstrated at a system level. Trade-off between components of a system is allowed. Simple spreadsheet-based calculation is sufficient, and slightly more effort is required. So trade-off is generally done on the building umbrella. As I explained earlier, that if you're not doing an energy simulation, but you don't want to install double glazed glass in areas that are not required, you can take this exception to this prescriptive method. You can show based on simple Excel calculation. The calculation, how to calculate, is provided in ECBC. You can say that, okay, despite of me not meeting all the prescriptive methods of the class, I'm still meeting the EPI ratio for the prescriptive. Right? So that ways you can. So these are the main two compliance approaches of the whole building simulation. I just want to take a hold of the time just to see. Okay, 25 minutes left. Okay, now coming to compliance requirement. Now, full building compliance. So new buildings will with completed fit outs shall comply with either the provisions of section 4 to 7 of the code or the whole building performance, right? So any new building, full building that has fit outs and everything, they will have to show the compliance either through prescriptive or the whole building. Core and shell buildings shall demonstrate compliance with ECBC requirements for the following base building systems in the common area. So in core and shell, you have to show compliance for building envelope. You have to show compliance for thermal comfort and controls, lighting systems and controls, electrical systems, and renewable energy system. So building envelope means just the outer shell, right? So lighting system controls that are only installed by the developers or owners. So as I said earlier, that what happens within the tenant space is not what the building developer should be concerned of. Only those systems that are installed by the developer or the owner shall be showed compliance with. This is for core and shell building. Now, additions to existing buildings, say building extensions and stuff, where new connected load demand of addition plus the existing demand exceeds 100 kilowatt or 120 kVA, the additional space shall comply with the provision of 4 to section 7 of the ECBC compliance. Right, compliance may be demonstrated in the following ways. The addition compliance is applicable, comply with the applicable requirements, and the addition together with the entire existing building shall comply with the requirements of the code. That's it. Right. So, for example, say if you have a building that has a contract demand of say less than 100 kilowatt, right? But with the additions, right, you exceed 100 kilowatt. In that case, the addition shall comply with the applicable requirements. You have the option of just complying the additional aspect with ECBC, or you can also choose to comply the entire building. That means your existing and your additional thing as a whole for ECBC. However, there is an exception when space conditioning is provided by existing systems and equipment. The existing systems and equipment need not comply with this code. That means you are just expanding certain aspects, but then the HVAC that is supplying to that new expansion area is still the same. In that case, your existing systems and equipments need not comply with this code. Okay, alterations to existing building where connected load or contract demand of the existing building exceeds 100 kilowatt or 120 kVA respectively, part of a building and its system that are being altered shall meet the requirements of ECBC section 4 to section 7. Right. In this, the exception is where the entire building complies with all the provisions of 4.7 as if it were a new building. So when an entire building is going for the compliance, right, it will be considered as a new building. But where the connected load and the contract demand of the existing building exceeds the ECBC requirement, part of that building and its 16, so only those parts that have been altered shall meet the ECBC requirements. Then approved analytical tools. There are some analytical tools that are there that can be used. First of all, a building following whole building approach shall show compliance through a whole building energy simulation software that has been approved by BEE. You can find the list in the like on the website of the approved list. Now, Equest is one of the approved softwares, right, which we will show in the subsequent sessions. Then compliance to daylight, if calculated through software tools, shall be shown through a daylight software approved by DE. Now there are various softwares through which you can do a daylight simulation. With Ecotech, you can do it in IES, I think. So these two are the main daylight simulation tools that you can use. Now, there are certain administrative requirements. The administrative requirements include, but not limited to, permit requirements, enforcement, interpretation, claims of exemption. So anything. So I think this basically gives you that a building that is that has ECBC compliant building will still have the administrative requirements that are written here. Now, there are certain compliance documents that are here. What I will do, as we are just short of time, I can quickly, I think this you can, this presentation will be shared here with you. I'm just quickly opening the ECBC code so that you can have a look at it. And ECBC code. Wait. Let me know if you can see the ECBC code. Okay. So as you can see in the ECBC code, I'll just quickly take you through so that the entire session makes sense. So as you can see, these are the various sections, right? These are the various sections, and here, as you can see, that every of those last few slides is said compliance through from section 4 to section 7. These are the main things that you must look into. So if you go to section 4, so here it says, so as you have seen that there are certain mandatory requirements under each section. Section 4 will have its own mandatory requirements. Section 5 will have its own mandatory requirements. Right. Section 4 has its mandatory requirements, and these mandatory requirements are relating to ventilation, minimum space conditioning, efficiencies, controls, piping and duct work, system balancing, for systems for building envelope. The mandatory requirements are how the U values are calculated. As you can see, daylighting is a mandatory requirement under ECBC. Now, ECBC provides you the option of taking simulation approach, or ECBC also provides you how to calculate manually that how much percentage of your building area GFA, your GFA complies with the daylight factor. So as you can see, every section, whether building envelope, they have a set of mandatory requirements and these prescriptive approach. So if you're taking the prescriptive compliance way, you first meet the mandatory requirements and then you go and meet the prescriptive requirements. Now, what are the prescriptive requirements? These. If you're taking the prescriptive approach, your roof U assembly should, so
So as you can see, they have given different U values for different climatic zones, 5 climatic zones, 5 different type of requirements, and based on the building type. As you can see that as per ECBC, there were classifications of the building. So hospitality has its own U value requirement for roof. School has its own U value requirement of the roof based on the climatic conditions. And similarly, there are 3 tables. So if you want to prescriptively comply for ECBC, you refer to table 4.4. If you want to prescriptively comply for ECBC plus, you refer to table 4.5. And similarly, if you want to comply with super ECBC, you refer to table 4.6 and these U values. That means your proposed case, your proposed building should match these values or be better than these values, right? In that case, okay. Now, now this is the same structure that is followed in every year. So similarly, that there are a set of mandatory requirements under your comfort systems and your controls. There are again and your prescriptive requirements. There are lighting control, your mandatory requirements and prescriptive requirements. For electrical systems and renewable energy, there are mandatory requirements and there are prescriptive requirements. If you come down, you will see the prescriptive requirements here. And this is the chapter that I was saying, that section 9. If you want to get your building ECBC compliant through the whole building performance method, this chapter should be your guiding thing. So here, if you come down, you will see this table. So section 9.4. This gives you what your proposed design should be, what your standard design should be. So as you can see here, that the standard designs shall be developed by modifying the proposed design as described in this table, unless specified in the table. So your proposed design and standard design should be the same. However, based on this table. So here, as you can see, space use classification, your standard design should be same as the proposed design. I think the Srivi Sagavi had asked about the standard floors, right? So from this you can see that the space use classification in the proposed should in the standard should be same as the proposed design. Likewise, operational schedules same as the proposed design. Now operational schedule means an hourly variation in occupancy, lighting power, equipment power, HVAC operations, right? So these should be same as proposed. However, there's an exception here that that schedules may be allowed to differ between standard and proposed model wherever it is necessary to model non-standard efficiency measures and or measures which can best approximated by a change of case schedule, right? So in case you want to change your schedules, you have to have a strong basis for changing. Say you are changing a schedule in the standard case. In that case, you have to, your standard case must have a justification that this occupancy profile is standard case based on international best practice, and then there should be a reference for the same, right? So similarly, if you can see here that there are different ways that this table provides you all the different ways in which a proposed case should be modeled under the whole building performance, and a standard case should be modeled under the whole building year performance. And then similarly, there are requirements for the lighting as well. Yep. So this table will give you now here, as you can see, this table gives you that what type of HVAC system you should choose for your standard design. So your proposed may have a certain HVAC system, but you cannot use the same system in your standard design. So this table will provide you the guidance of how to choose your system in the standard design. All these things we will come across while we will be doing the hands-on training on the eQuest. And then this all will further make more sense in those things, in those sessions when you will be actually developing the geometry, where you will be actually inputting those efficiency figures here and there, and then when you will run the simulation, you can see that how varying those factors will give you the variation in the total energy consumption of the building throughout the year. So this was an introduction on the entire ECBC. I'm not sure how clear I was. I hope I was helpful to you, and you have a basic idea of what ECBC is, how the structures are, how it came to existence, what are the different building classifications, what are the different aspects of ECBC that are there that you can change to make your building ECBC compliant or more energy efficiency or more energy efficient. We have 10 minutes more, so I open the floor for any questions that are there, if you have any. Are there any questions? You can just unmute your mic and say, or you can type your questions in the chat box. Yes, Shrikant, I hope I'll send you the presentation and then you can share the presentation with all the participants, right? Or have you already shared this?
This participant, no, sir. This one ECBC, yeah, amendments we already shared, sir.
Okay. No, the presentation?
Presentation not shared, sir. We will share it, sir. No problem.
Okay, there is a question that says, is ECBC applicable for factory
buildings. Factory buildings, I mean, again, this is a gray area. ECBC may be applied for factory buildings. Earlier, ECBC has been applied for factory buildings. Just that your your main manufacturing section will not, so ECBC will not be applicable on your manufacturing gear sections, and all those loads and those lighting requirements in the manufacturing section will not be applicable. But in spaces where you have offices or other things, or say dining halls and stuff like that, all those places you can apply ECBC, because as you said that because ECBC gives a very basic thing that anywhere where ECBC will interfere with the main purpose of the building, it will not be applicable. So anything, I mean, it can also be argued that factory buildings, if you have lower lighting, there will be health and safety issues. People will not be able to see clearly, say signages or anything. Signages needs to be, exit signs needs to be bold and visible. There is a factor in ECBC prescriptive requirements that gives a maximum allowable wattage to exit signs or signages. So all those things will not be visible, and as it will directly impact the health and safety of the workers, ECBC will not be applicable to those areas.